All right, we are now going to look at section 2 of Unit 5, which is the physiology of the skeletal system. All right, so you do have calcium running through your bloodstream. We talked about calcium in Unit 2 as one of the elements that's needed by your body. Blood calcium levels are critical for normal functions of your muscular system and your nervous system. So calcium is used during muscle contractions, and it's also used when your neurons or your nerve cells communicate throughout the body. All right, so where can calcium be found in the body? It's found circulating through your blood. It's also stored in your bone. Again, calcium is what makes your bone very dense, very hard, and makes it strong. It can be removed from bone when needed and put into the bloodstream, and then it can be stored in bone when you have higher levels in the blood and you don't need that much. Okay, so it can be put back into bone. You have those osteoblasts. Remember we said those are the bone building cells, and you have osteoclasts, which are the cells that break bone down to release calcium. Those two together, along with some hormones, help regulate the homeostasis between the calcium found in your blood and the calcium found in your bone. All right, so you have hormones that are going to regulate this calcium homeostasis. There are two of them. The first one we're going to talk about is called PTH, or parathyroid hormone. That's what the PTH stands for. And it is secreted by your parathyroid glands in your neck. And this is your windpipe. You have this thyroid gland here. That's the bigger one. And these small little glands that are in a color of kind of a purplish color, those are parathyroid glands. So this is where PTH is secreted from. All right, what does the hormone do? Well, it's going to stimulate your kidneys to help produce active vitamin D. Vitamin D is very important to helping your body absorb calcium. Okay, and your body doesn't do a very good job at absorbing it from your food and your intestines by itself. So vitamin D is going to help with that. It stimulates the increased bone breakdown. Okay, so this is uniform throughout your skeleton. So what it's going to do is when your blood calcium levels get low, it's going to increase blood calcium levels by breaking some of the bone down and releasing the calcium. Okay, it's going to stimulate osteoclasts. Remember, osteoclasts are the cells that break bone down. And as it's breaking it down, it's releasing the calcium. All right, and then it also increases calcium reabsorption in the kidneys. So your blood is regulated throughout your body, and it flows through your kidneys. The kidneys are there to remove wastes, and sometimes it removes other stuff as well, maybe excess calcium if your body doesn't need it, along with some other things. We'll talk about it when we get to the urinary system. But in this case, if your body needs the calcium, it's going to reabsorb it instead of letting you pee it out. Okay, so PTH is there to help increase calcium in the blood when blood calcium levels get low. On the other hand, if your blood calcium levels are decent, high enough, then you're going to have this second hormone called calcitonin. It is secreted in the same area, but this time the bigger gland we said was called the thyroid gland. Again, it's on the windpipe, and that's where it's going to come from. And what this hormone does is decreases the osteoclast activity. So it's going to slow down those cells that are breaking the bone down, which is going to decrease blood calcium levels because it's going to allow the calcium to stay in the bone. And also it increases the osteoblasts, which are going to add the calcium from the blood, or some of the calcium in the blood, to the bone. Okay, so it's going to help, balance out the amount of calcium in your blood and help maintain it. Okay, if it's gotten too high. So if blood calcium levels have gotten a little high, calcitonin is going to be the one that comes in and starts putting the calcium, or help regulate putting the calcium back into the bone and take it out of the bloodstream. All right, so looking at bone growth in the beginning, and you can see in this picture here, we're looking at a fetus, okay? And then this is still a fetus, and you get to childhood and versus adolescence. Bones are going to start growing during fetal development, of course. Babies have bones. And it all starts out as cartilage. Okay, so this whiter, bluish white, that's cartilage, where the yellow area is actually hard bone. Okay, so ossification is just a fancy term for bone formation. And again, all bone starts as cartilage, and the osteoblasts are the cells that carry out the process of bone formation. Bone growth in length or height will continue to occur until about 18 to 24 years of age. And when you get into those higher years, generally it's the male that will continue to grow. Females don't generally grow that late. Girls tend to stop growing about the time that they, hit puberty, and their girls' puberty is marked by their period, getting their first period. So generally girls don't grow in height that much, maybe 2 or 3 years after they get their period, but then after that they slow down. All right, so if you look at these, you can see how the bone is forming in the yellow area, orange area, and you can see even in children, there's still a lot of cartilage here on the epiphyses. But when you get to be a teenager, your bones are about what they would look like if you were an adult, and you just have that growth plate that we call the epiphyseal line, which we'll talk about in a minute, epiphyseal plate. And that's where your bone grows from. Let's look at this epiphyseal plate. So ossification or bone formation in height occurs along the epiphyses. So remember the ends of the bones at an area called the epiphyseal plate. This is called the growth plate. Okay, osteoblasts, the bone building cells, are going to build bone at this point. And again, it starts out as cartilage. That cartilage will eventually turn into spongy bone, which looks like this. And then eventually it turns into the compact bone, which is the harder, stronger bone. Okay, let me let my kitty out. Hold on. Okay, so looking at our picture here, you can see the epiphyseal plate right here. It's right at the base of the epiphysis, almost getting into the shaft area, okay, which we call the diaphysis. And this is just a X-ray showing there's your epiphysis, there's your growth plate right here, and then the diaphysis is down here. All right, another picture just kind of showing you got the joint cartilage or the articular cartilage around the end of the bone, but this line right here is that growth plate or epiphyseal plate. It shows you how cartilage is forming, and then the cartilage will become bone on the inferior side. Just another picture, again, demonstrating the amount of cartilage found in babies and young people versus adults. Okay, so when do you stop growing in height? Okay, what happens when you stop growing in height? Ossification in length or height ends anytime from adolescence to about age 24. Epiphyseal plate, again, that's where it used to grow from, but at this point, when you do stop growing in height, the cartilage there is going to solidify into bone, and growth stops, at least in height. Okay, you don't really grow any taller, or your bones don't grow longer. They continue to grow like outward, and we'll talk about that in a minute. But this area of the bone that used to be the plate is now going to turn into something we call the epiphyseal line. And again, it's just where the cartilage has solidified and it no longer is going to produce new cells for lengthening the bone. And when that occurs, you don't get any taller. Okay, we're looking at these x-rays. I guess unless you're a doctor, you really can't see too much of a difference. But this is an open showing the growth plate as it's actively growing, and then this one is where it's not actively growing anymore. It's solidified into bone. All right, so we've been talking about growth. You also have something called remodeling that occurs, and remodeling occurs throughout your lifetime. So the growing in length or height stops, we said, around adolescence, where bone remodeling happens your whole life. So what happens during bone remodeling, or why does it happen? Well, this is the part where you get the regulation of the blood calcium homeostasis, where if you need calcium in your blood, it's taken from the bone. If you got too much calcium in your blood, it's added back to bone. This is a constant process, and it's uniform throughout your skeleton. So that's bone remodeling. It's also, bone remodeling is there to help repair micro damage to bones during everyday stress. So you're doing all kinds of stuff all day long. You know, that some people more than others, depends on how physically active you are, what kind of job you have, but you have little micro fractures and stuff that happens to bones you don't even know about. So this bone remodeling is going to be there to repair that. And then it helps to shape the skeleton during growth. So, I mean, you're still getting larger. Some people are, may not in heights, but other ways. So you're shaping your skeleton that way. And then it's also to help with compensation. So if you get injured, one leg is injured, so you have to like walk on the other leg even more, the bone in the leg you're walking on will get stronger. If you like start bodybuilding and stuff and start adding the extra weight and stress to your bones will strengthen as well. Not just your muscles, but your bones will too. Okay, so that's what bone remodeling is all about. So this is where your existing bone can be removed by osteoclast, and then new bone can be deposited by osteoblast, just depending on what process is occurring. But it's still occurring through those osteoclasts and osteoblasts, bone building cells and bone breaking down cells. All right, so during your first year of life, they said almost 100% of your skeleton is replaced. Remember, when you're a baby, it's not that much bone anyway, it's a lot of cartilage, but that's why almost 100% is replaced, because even the baby's body is, you know, regulating calcium, blood calcium. It's still going on, even though they're an infant. In adults, they say about 10% is replaced each year. And again, that has to do with that whole homeostatic balancing out blood calcium and the calcium in the skeleton. And so they said you have a new skeleton, if you want to look at it this way, about every 10 years. This is just a picture showing, you know, here's some active osteoclasts with their, you know, removing some of the calcium and releasing it. And then down here, you have the osteoblasts that are coming in and reforming bone. Okay, here's just another picture showing, again, osteoclasts that have come in, and this is on a very microscopic level. So it's not like you're getting huge holes eaten in your skeleton. And again, this is uniform throughout your body. So these are just little tiny microscopic trenches left by the osteoclast, where it released some of the calcium. And then you have the osteoblasts come in and start building the bone back to fill those trenches. All right, let's look at what happens during broken bones. You break a bone and your bone has got blood cells. Remember, we said the red bone marrow actually creates their red blood cells, but remember, blood cells are there to help distribute oxygen. Your bone is a living tissue, so it needs oxygen. So those blood vessels that are found in the bone along the break can be damaged. And of course, you damage a blood vessel, you're going to get bleeding and then clotting. Once that happens, you're going to start, as your body starts to heal, a fibrous network of connective tissue starts to form at the break, trying to hold it together. Now, it's very weak connection, but it's forming that connection. And then eventually cartilage is going to be added. And this area of tissue repair is called the callus. Okay, so eventually cartilage will be replaced with spongy bone. That takes about 4 to 6 weeks, which is about the time you would be wearing a cast. And then eventually compact bone is going to be there to replace the spongy bone. However, it can take several months for the bone to return to normal strength. So, all right, some types of bone fractures. You have, here's your normal bone, but you have a transverse break. If you remember from Unit 1, you know, transverse is that horizontal cut. So that's a nice clean transverse cut. You have oblique. Remember, we said that was kind of a diagonal cut. Spiral fracture occurs when it's twisted. Then you have this one right here, where it's basically crushed in this area. And the avulsion is where you're kind of cutting off part of the head of the bone. Impacted means that, you know, the bone was forced together, so it's kind of cracked there due to the compression. You have fissures that run along the bones here, and then this green stick is just where you have a break, but it doesn't go all the way through. Here are some interesting skull injuries I found. These are depression fractures. This is the x-ray. This is showing the guy's head. This guy was a fighter that got elbowed in the forehead. They said that he came out all right with no brain damage or anything, but that's terrible. Here are some backbone injuries just to show you with your vertebrae, because remember, your vertebrae is here to protect your spinal cord. Because if you damage your spinal cord, you could be paralyzed. Okay. So this is showing the damage to the bone here, and then it looks like the spinal cord was compressed. I don't know the story behind this, so I don't know if this person was paralyzed or not. And then this is just a picture showing where they had to use pins and plates and stuff to stabilize the backbone for it to heal. Now, you can break your back and not be paralyzed as long as you don't damage the spinal cord on the inside. And when you damage the spinal cord, that's when you start to run into problems with being paralyzed. All right, you have incomplete fractures, which means it doesn't break the bone all the way through. And you have complete fractures, which means you did pretty much break the bone all the way through. All right, this one's pretty. I tried to find the prettiest picture, but this one amazed me because this is an open fracture, of course. So you have open fractures, which means the bone is poking through the skin. And then you have closed, which means you have a broken bone, but it did not come through the skin. This one amazes me because this is the femur, which is the largest, strongest bone in the body. I tried to go and look. I went to this website and actually looked to see if they had the story behind it. They did not. But whatever happened to this person, I just, wow. Because one, they broke it right off and it is sticking out of their body. At first, I didn't think it was real, but then, like I said, I went to the website and it's a medical site. So it's a real picture. I just wish I knew the story behind it. All right, so that's the end of our notes for section 2 of Unit 5. If you guys have any questions, you know where to find me. Have a great day.